Okay, so today and tomorrow we're going to talk about the law of sines and the law of cosines. Okay, why do we have the law of sines and cosines? In the past 2 chapters, what kind of triangles have we been working with when we've had triangles? Right triangles. Are all triangles right triangles? No. They're not, are they? Okay. Those triangles that are not right, we don't call them wrong triangles. We call them oblique triangles. Okay. So oblique triangles are triangles that do not contain a right angle. Okay. That's what we're going to be working with the next few days. Now, what we're going to do is we're going to solve them, meaning we're going to find all of the angles and all of the sides. Okay? In order to do so, we must be given 3 parts of our triangle so that we can find the other 3. Okay? So these are the pieces of information that we would need in order to be able to use the law of sines formula. If we know 2 angles and 1 side, it does not matter the order, so angle, angle, side, or angle, side, angle. Okay, so it does not matter if the side is in between the angles or outside of the angles. Then we can use the law of sines. If we have 2 sides and an angle that is opposite one of those sides, then we can use the law of sines as well. Okay. Now, if you looked at the book problems that I gave you last night, they were the cases where you had 2 angles and a side, right? Okay, so here is the law of sines. It's basically 3 different proportions. The sine of angle A over side A should be equal to the sine of angle B over side B, which is also equal to the sine of angle C over side C. Okay? You are not going to use all 3 proportions at the same time. You're going to pick 2 fractions to set equal to each other to solve for a missing piece. Since it's Wednesday, we're going to kind of cut shorter on time. At the end of class, if there is time, I'm going to come back and I'm going to prove to you why the law of sines formula is what it is. Okay? But I want to get through our examples first. So we're going to get through examples and then I can come back and show you why this formula works. Does that work for everyone? Okay. Make sure you also write down this area formula. Okay. Well, what it is, okay, if we know 2 sides and an angle in between, then we can use this formula. Okay, so if we know A, B, C, if we know side B and side C and angle A, then we can find the area of the triangle using this formula. Okay. So you can write all of them down, or you can write one of them down. It does not matter. Okay, so we're going to start with a basic example. This is an example of what the kinds of problems that you saw last night. Okay. Here we have angle A is 32 degrees, angle B is 50 degrees, and side C is 18.7 centimeters. Do you see a triangle up here? So what should you do? You should draw one. Okay. So angle A is 32 degrees, angle B is 50 degrees, and side C is 18.7 centimeters. We have angle, side, angle, so we know we can use the law of sines. What's the first thing that we should find? Angle C, right? We should find first. These three should add up to 180, so angle C should be what measure? 98. My picture is obviously not drawn to scale. It's okay. If it bothers you, redraw it. Okay. Now, we need to pick a side to solve for. Do you want to solve for A or B? Great. We will solve for A. Okay, so the law of sines. The sine of angle A over side A equals, okay, we should probably pick the angle that we know is side opposite, right? The sine of 98 degrees over 18.7. Get your calculators out. First of all, make sure it is in degree mode. Second of all, please be careful when you do this cross multiplication. When we cross multiply, we're going to take A times the sine of 98 degrees equals 18.7 times the sine of 32 degrees. So to solve for A, you'll have to divide the sine of 98 over. What do we get? .001.
I said 0.006.
Oh, I'm sorry. Okay. Now, I'm not going to go through the calculation for finding B because I want to save some time and get to the ambiguous case. All right. If we go to find B, let's just set it up. The sine of 50 degrees over B should equal. The more given information you can use, the more accurate your answer is going to be. So yes, we know angle A and side A, but I would rather you pick angle C and side C since that has more given information to use. Okay. Otherwise, you might be just a little bit off from either the back of the book or my key. Okay. All right, so let's talk about this ambiguous case. Okay. The ambiguous case is when we have, we are given a side, and then an angle. Okay. Now, there are three possibilities when we are given a side, and angle. Our first possibility is that we do not get a solution. We could get one triangle solution, which we're kind of used to. It is also possible to get two solutions that work. Let me show you why. I have a pipe cleaner triangle taped to my board. I know it's not very fancy, okay, but it's going to get our point across. Okay, so side, angle. What is in pink on my board is our given information. So this blue pipe cleaner, that's a side that I don't know. I don't know how long it is. okay? But I know this angle and I know these three sides. I don't know this angle up here, okay? Now, no matter how I move this side, can I make a triangle? Okay, so it is possible for me to be given an angle side of a triangle, and it's not going to work because this side is going to be too short to ever meet. This is what it would look like to have no solution. Okay, now I'm going to adjust our given angle. To here. Okay, so here's my angle side. If I adjust my angle up here, notice how my pipe cleaner meets that blue side once. So here would be my one solution of a triangle. Okay. Now what's going to happen if I'm given an angle small enough with my sides? What happens as I adjust this angle up here? I can make a triangle this way, right? Or I can make a triangle that way. You see that? I can make a triangle here, or I can make a triangle here. So when we are given information of a triangle, side angle, we have to check to make sure, are there two triangles that work? Okay, now, look at my picture up here. What do you think the relationship is between this angle in this solution and the same angle in this solution? Yes, this angle in this triangle and this angle in this second triangle, they're going to be supplementary. Everyone see that? Okay, so we're going to use that to help us when we solve our second triangle. Okay? All right, so here's our given information. We have A is 40 degrees, side A is 54, side B is 62. The first thing you should do is draw a triangle. Okay. So here we go. What is the first thing? Okay, first of all, we have two sides and an angle not included. So this is a side angle. We know we have to use the log sign. We also know this is going to be an ambiguous case, so we have to see if there are going to be two solutions. Okay. What is the first piece of information we have to find? The only piece we can find right now. What? Angle B, right? In order to set up our log signs proportion, we need an angle and its opposite side, right? So we have angle A and side A, so we can set up this part of the proportion. We also know side B, so we can set this equal to the sine of B over side B. So now, when we solve this, let's talk about it. We have 62 times the sine of 40 degrees equals 54 times the sine of B, which means the sine of B is 62 times the sine of 40 degrees all over 54. How do I get angle B? The inverse. So you need to take the inverse sign of whatever this number is right here. Take the inverse sign of whatever this number is right here. 47.56. We're going to go to 2 decimal places, okay? So if I go up to my color cleaners over here, okay? Basically what's happening, well, this looks better. This angle is 47.56 degrees, okay? Now, we can continue and solve for this triangle, right? So I'm going to take a moment and we need to see, is there going to be a second triangle? Okay? So if there is an angle, or if there is a second triangle, what is true about angle A, angle B in the second triangle? It would be supplementary. So I'm going to go over here. Here's our second triangle, right? So angle B would have to be 180 minus 47.56 degrees. What does that give us? When you do the log signs, I want this to be the first thing you do so that you don't forget about it. All right? I want you to find the first angle, and then I want you to find that same angle in your second triangle. That way you don't forget to check for a second triangle. Okay? So we're going to come back to the first triangle. Okay? If we know that angle B is 47.56 degrees, what can we find now? We can find angle C, and that's pretty easy, right? We just need these to add up to be 180. So go ahead and take 180 degrees minus 40 minus 47.56. What is our angle C?
92.
You agree with Sean? You read it off. Okay, I was turning it on. All right. Now what can we find? Side C. We have angle C. We can now find side C. Okay, so we know that the sine of 92.44 degrees over side C should equal, what pieces of information do I want you to grab? I want you to use angle A and side A because that has the most given information. So the sine of 40 degrees over side A is 54. Okay. So what is side C? All we have to do is cross multiply, right? Sine of 92.44 times 54 equals the sine of 40 times C. Is anybody doing this for me?
Yeah.
That is perfect. Okay? I want every single one of you to be doing this in your calculator so you know how to work your calculator. Okay? So please be doing this along with us. Make sure you're getting the answers that we are. Okay? Okay, so here's our first triangle. Let's go ahead and go to the second triangle. Do we have a second triangle? Right now we have in our second triangle, angle B is 132.44 degrees, right? So I'm gonna redraw my triangle. And we know angle B is 132. Okay. So now we need to solve this triangle right here. Okay? All it is we have another triangle to solve. It's kind of having like two problems in one, right? What's the next thing we need to find in the second triangle? angle C. Okay, right? What is angle C in our second triangle? We need to take 180 and we need to subtract 40 and 132.44.
7.56. What did you say you subtracted?
Well, our angles, A is still 40, but B is now 132.44. So those are the two angles we subtract from 180. Okay, we still have all of our given information. Okay, now in this second triangle, we have side C left. Okay, well, our second triangle has an angle for C of 7.56. So we're going to say the sine of 7.56 over this side C should be equal to, okay, we can grab our A angle inside, sine of 40 degrees over 54. Okay, so we can do our cross multiplication, right? The sine of 7.56 times 54 equals the sine of 40 times C. So here we have two solutions. We have two triangles that work. Our side was long enough that it could rotate to hit that third side at two different places. Okay? When I see your work, I want there to be a clear distinction between where is my first triangle, where is my second triangle. See how I kind of split my page in, well, half, not really in half, but I made kind of a line. Okay, here's my first triangle. I wrote over here second triangle, and I drew another picture for it to help me. Okay, make sure I can tell where is your first, where is your second. Yes.
So this, we're going to do two triangles. You want to do it for side angle.
The only time we are going to get two solutions is side angle. Any other questions about this example? Yes.
How do you know what angle is?
For which part? Okay, good. That is a great question. The angle that you are going to use to subtract from 180 for your second triangle will always be the first angle you find. So since we could only find angle B, that is what we use to subtract from 180 for our second triangle. And it's always the first angle that you find. Great. Okay. Let's look at other examples so we can see what it looks like to have the other kinds of solutions, whether we don't get a triangle at all or we only get the one triangle. Okay. So here's our next example. Okay, so I'm going to draw a triangle. ABC. Side A is 205. Side C is 314. And side C is 35 degrees. Okay, so you notice how we have side angle. Our angle is not in between our two sides. Since it is side angle, that tells us that we must use the law of sines. Okay? That also tells us that we have the ambiguous case, which means we could have 0, 1, 2 solutions. We have to check for the second triangle. Okay? So here we go. What do we have to find first? We have to find angle A. We have both pieces of information about C. We have one piece of information about A, so we're going to find angle A. So the sine of angle A over side A should equal the sine of angle C over side C. Okay, so let's talk about how we would solve this. We cross multiply. So the sine of A times 314 should equal 205 times the sine of 35 degrees. So we're going to get that the sine of angle A is 205 times the sine of 35 divided by 314. To remind ourselves, how do we find the angle if it's inside of sine? Inverse sine of that value. Please, everybody try it in their calculator so they remember how to do it. Make sure you're getting the correct answer. I'm going to show you something, maybe. Okay. Okay. So we're taking the inverse sine of, help me out, was it 205? 205 times the sine of 35
Yep.
divided by if you want to keep that for later, do you guys know how to store numbers in your calculator? Okay, if you want to keep something for later, this STO button right here, you can say store, and if you want to store it in A, you can say alpha A. That way, anytime you bring up A, it's that number. Okay. So, back to our notes. What was that angle? 21.99. Okay, so let's talk about our potential second triangle. Okay, the reason why I want you to do this now is so you don't forget which angle to use to find our second triangle. We found our first triangle, or our first angle. In our second triangle, what would angle A be? How do you find it? 180 minus what you found in the first one. What would that make it? 158 point what? Anybody see an issue with that? What's the issue?
35 and 158 add up above 180.
Okay, our angle C is 35 degrees. Angle A is 158 degrees. Can we have more than 180 degrees in a triangle? No. When this happens, that means our second triangle does not exist. Okay. All right. So now we need to find angle B, correct? So if we go back to our calculator, we can say 180. We can say 180 minus 35 minus A. We don't have to type it in again. And there's our new angle, which was what? 120.01? Oh, 123.01. Okay. And then to find side B, we can take the sine of 123.01 over side B equals, what pieces of information do I want you to use? C. The sine of 35 degrees over 314. So side B, I'll just do the calculation for you, is 459.07. Okay, we still have 3 minutes, so please do not panic. I know the bell's gonna ring. Our last example will take about 2 minutes. Okay, it's going to be very quick to talk about. What do you think is going to happen? Okay, we have A is 30 degrees, side A is 2, side B is 6. We have side angle. It's the ambiguous case law of sines. What piece of information do we need to find first? Angle B. So we have the sine of angle B over 6 equals the sine of 30 degrees over 2. When we cross multiply to solve, we get the sine of B times 2 equals 6 times the sine of 30. The sine of B equals 6 times the sine of 30 degrees over 2. In your calculators, inverse sine of 6 times sine of 30 divided by 2. Inverse sine of it. Yours says error. What's the sine of 30, ladies and gentlemen? A half, right? What's 6 times 1/2 divided by 2? 1.5, right? Can we take the sine? Is there an angle that's going to give us 1.5 for a sine value? No, because it's over 1. When you get an error in your calculator, that means we cannot find that angle, which means what? There is not a triangle. There is no solution. Okay? So your homework. If you did not get these problems from last night's homework, you should. Okay? To tack on to that, you have 1, 2, 3, 4, 5, 6 law of sines ambiguous case problem. Okay? Not a lot of problems to do. Okay? But it's important that you do them so you understand what happens with this ambiguous case. Alright? Just because you're not in the homework club does not mean you shouldn't do your homework. It means you still should. You just don't get graded. Happy Wednesday!